Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now I am going to explain the topic hybridization in ethine. Ethine means CH2 the triple bond CH triple bond CH, that is ethine. Now this is part 4. In part 1 methane, part 2 ethane, part 3 ethene. Now it is part 4 where I am going to explain ethane. CH triple bond CH. Now what is the electronic configuration of carbon 1s2 2s2 p2? Then ground state of carbon. But that means here it is K cell. It is our K cell. It is our L cell. Now in K cell 2 electron, L cell the outermost cell, that is L, containing 4 electron. Out of 4 electron, 2s contain 2 electron and p orbital which contain 2 electrons. And here according to Hund's rule, each orbital should contain one unpaired electron until it is not completed. So here it contains one unpaired electron. If more electron then comes to here, if more then only it will pair. Now there are 2 electrons, so it cannot pair. It simply px py contain each 1 electron. Now here indicates 2 unpaired electron, 2 bonds can be formed, but we know carbon is tetravalent. Here 4 valency of carbon is there, and that is why here we can't say out of here the bond is formed. Here only bond is formed, no, because here the bond should be 4. That means here unpaired electron should be 4. So excited state of carbon, this 2s electron jumps to here where electron comes to here pz orbital. Now as 2s 1 electron, p2 px2 py2 pz all are containing 1 electron each. That means here how many electron? 3 plus 1 4 electron, which are each unpaired electron. They are capable to form bonds. But again scientists thought if the bonds are formed, since S is the lower energy and P is the higher energy, the 4 bonds should be different. One bond should be less energy, other bond should be higher energy, but actually it is not formed. It is observed by the scientists that all the 4 bonds which are formed, that is having equivalent energy and equal length, then what happened? Then the word sign, that is hybridization, takes place. The word, what is the word hybridization means? Combining of orbitals having different energy and redistribution equally in a new orbital having equivalent energy, equivalent length, and that is called hybridization. Hybridization are so many types: sp3, sp2, now it is sp, and others are there, but organic chemistry generally sp3, sp2 and sp, these 3 are mostly used. Now here the hybridization is sp, because here if hybridization sp, then what are the on-hybrid orbital? This is this one on-hybridized orbital py, pz. They are not in the part of the hybridization, they are separated. Only S and px electron they will combine. These 2 orbitals, one is spherical, symmetrical, other one is dumbbell shape. Both will combine and forms, that is sp hybrid. Sp hybrid or not orbital, hybrid orbital. Sp hybrid orbital, here one middle, that is very small one, and big 2 lobes are there, and that each one containing 1 electron, and this big part, big spherical, that is called sp hybrid orbital. And here what happened, this sp2 hybrid sp hybrid orbital containing 1 electron. This is responsible for the bonding with others, and the process is called sp hybridization. Sp hybridization, where this is called sp hybrid orbital, and here you can find these 2. This is what py and this is what pz. They are not undergoes in a part of the hybridization, and this is called unhybridized orbital, and each containing 1 electron each. After that we will see this unhybridized orbital py/pz, how they will interact, how they will overlap and form our other bonds. So I hope clear. Electronic configuration, ground state, then excited state, then hybridization. Here only remember sp hybridization, and here other remaining, that is py/pz, that is unhybridized orbital. After that you will see how the bonds are formed and to form CH, triple bond CH. I told in ethine sp hybridization takes place, that means carbon has sp hybridization. There are two carbons in ethine, so they undergoes sp hybridization. What is the formula? CH, triple bond CH. That means here you can write like this. That means C2H2. C2H2 and triple bond in middle. So this carbon undergoes sp hybridization, this carbon also undergoes sp hybridization. This is the sp hybridization I told now, and sp hybrid orbital here is containing, there are two lobes, two orbitals, they containing 1 electron each. This is one carbon, carbon 1, this is carbon 2. There are two carbon which contains 1 electron each. Now here you can say this is the sp hybridization this carbon, and this is the sp hybridization this carbon. Now they overlap each other, they both will overlap each other and form bond. This is sp bond. And now this electron which is remain here, that will overlap with 1s orbital of hydrogen. See, again you can see the diagram here. How can I drawn here? There are two lobes here, one lobe here, one lobe here, and electron, one electron. This electron overlap with other. See, this is the overlapping of these two, and this side remaining 1 electron, this is overlapping with hydrogen, this is also overlapping with hydrogen. That means here this is one bond, this is one bond, this is one bond, this is also sigma, this is also sigma sigma, but this sigma is sp sp, this sigma is sps, and this sigma is sps. Are you clear? That means here you can say this is the carbon 1, this is the carbon 1, where this side overlapping takes place with hydrogen, this side overlapping takes place with the hydrogen. So the result will come like this. What is the result? C, C, H, H. All are sigma bond. All are sigma bond. And this sigma sp overlapping, this sigma sps overlapping, this also sps overlapping. After that we know py is vacant. Sorry, py is not undergoing hybridization. Here it is containing 1 electron. Similarly, py here also containing 1 electron, is both are unhybridized orbital. So they can overlap with each other. Lateral overlapping, having two lobes, that means one pi bond is formed. So here py 1 pi bond. And pz also there, pz also unhybridized orbital which can make overlapping, that is lateral overlapping, and forms pi bond. So here you can write py, and here also you can write py. See the diagram. So here overlapping takes place here py come pz, and here pz. Though pz overlapping takes place. Sorry, one is py, other one is pz. Py overlapping takes place, that is pi bond form, and similarly pz overlapping takes place, that form pi bond. So it forms pi bond. Are you clear? So you do the diagram just like this. Py, Py overlapping takes place, and it is one pi, that is Py overlapping, Py, and if you write Pz is contain one electron, one low. Here also Pz, that is pi bond, and here also pi bond. Now I hope it is clear how the Py overlapping takes place. Py overlapping takes place from pi bond, and Pz overlapping takes place from pi bond. So how many pi bond? 1 and 1, 2 pi bond. So the structure is here. This is, you can write here like this. This is sigma. This is sigma. This is pi. This is pi, and this is sigma. You know this sigma SPS, this sigma SPS, this sigma SP of carbon with SP of carbon, and this one lateral overlapping Py, Pz. Now it is completed the hybridization in ethine. How can you explain hybridization ethine? First of all, you will do the sp hybridization. After that, you will do how the overlapping takes place, between sp hybrid orbital of carbon with s orbital of hydrogen, and how the overlapping takes place between sp orbital of carbon, sp orbital of carbon. So I hope clear. And how many? See, there are 2 pi bond, 3 sigma bond, 1, 2, 3 sigma bond, 2 pi bonds. How they form, it is clear. I hope it is clear to you, and hope subscribe my channel BL Das Short and Sweet in Chemistry. Thanks for watching my video. Thanks again to all. If after that I will come to next video for the topic structures of methane, ethane, ethene, ethyne after hybridization. After hybridization, what are the structures possible here? We will see in coming video. Thank you again.